second derivative. Keep in mind, so now we have seen from the differentiation of a vector that in case of vectors, your operator is d by dt is equal to d by dt change in magnitude plus omega cross whatever p, right? This is your operator. So this happens, this operator has to be used wherever we are differentiating a vector. Now, and okay, so now if you want to go for accelerations, right? If you want to take the second derivative of p, so now we have d by dt of v. In this case, you have for vector v, you have dp by dt, this is a vector, omega is a vector, and p is a vector. So you will get three vectors, 3 to 6 components, right? So you have for the first component, you have first component, yeah, you have change in magnitude. So d by dt of dp by dt plus omega cross dp by dt. This is the first, and then you have omega cross p here, right? So you have plus d by dt of omega plus cross p plus omega cross p. Then you have plus omega cross dp by dt plus omega cross p. So now here omega cross omega is 0 in this case. So in omega cross omega is 0. So this is 0. This is gone. So you have omega cross dp by dt twice, right? One is here, and the other is here. So this is coming 2 times, and then you have, so now let us write it, dv by dt is equal to d square p by dt square plus 2 omega cross dp by dt in parenthesis plus this is nothing but alpha cross p, and plus you have this plus omega cross p. Now this, so acceleration has 4 components. So d square p by dt square is change in magnitude, so therefore it is along, obviously, yeah, right. So this component will be along, direction of this will be along p, or basically in the direction of d cap, right? Okay, along p. Let us write it in terms of p. Now omega cross dp by dt. dp by dt is along p, and omega is k cap out of the plane of the paper. So omega out of the plane of the paper and d is along this line. So now omega cross d will be along perpendicular to. So this component will be, let us change the color. This is the Coriolis component. This will be perpendicular to P. Alpha cross P also will be perpendicular to P. Also perpendicular to P. Omega cross P. So now this component, this will be omega cross P. So what will be the direction of this? Omega cross P is, in pure rotation we have seen it is dP by dt. In that case it is along P. Omega cross P is along P cap, which is perpendicular to the vector P. Now omega of that, so now we have omega is again out of the plane of the paper. So if you do the right hand rule, omega cross P, you can see that it is in along P but inwards. So along P but or in the direction of minus d cap. This is in the direction of d cap. These two are in the direction of P cap, right? So these are the directions of various components. Okay. In the case where you don't have, you have pure rotation, right? When you have pure rotation, your acceleration can be written as alpha cross P plus omega cross P. So in these videos we will write this as alpha component of acceleration, and this will be written as omega component of acceleration. Okay.